Okay, so today we're going to be talking about direct variation. So let's take a look at a couple of equations, and it says to find and plot three solutions of the equation. Alrighty, so y equals 3x. So a solution of the equation is a number x and a number y. When they get substituted in, they make the equation true, okay, or they give you a true statement. Sometimes we'll do this like using a t-table, where you do an x and a y, and you choose some x's. Usually it's good to choose like a negative x, 0, and a positive x, and then you simply substitute in. So 3 times negative 1 is negative 3, so y would be negative 3. And then 3 times 0 would be 0. And then 3 times positive 1 would be 3. Okay, so those are our three solutions of the equation y equals 3x. And then it says to plot them, so that means put them on the graph. So negative 1, negative 3. So to the left 1, down 1, 2, 3. 0, 0. Okay, that's our origin. And 1, and then up 3. Okay, so we found and plotted three solutions of the equation. Okay, now over here, when we do our t-table, I'm going to be a little more deliberate in picking my numbers because I have a fraction, and I have learned over time that if you pick an x value that is a multiple of the denominator, then you don't have a fraction in your answer. So I'm going to choose negative 2, 0, and positive 2. Okay, so if we go through our process, 1/2 times negative 2 is negative 1. Okay, and then 1/2 times 0 is 0. And 1/2 times positive 2 is positive 1. So our plotting would be negative 2, negative 1, 0, 0, and 2, 1. Okay, so we would say that each of those points is a solution or represents a solution to the equation. So how can you describe the relationship between two quantities that vary directly? That's going to be the question we're going to try and answer today. How can we describe a relationship between two quantities that vary directly? Okay, and that, you may have noticed, is basically the title of your notes, direct variation. Okay. So the first thing we have here is to determine whether x and y show direct variation, and if so, identify the constant of variation. All right, so two parts. Determine whether x and y show direct variation. In order for it to be direct variation, okay, the equation should be able to be written as y equals kx, which basically means it's going to be a line through the origin. Okay. It's going to be a line through the origin. K stands for our constant of variation. So the easiest way to show that it does, or to determine that it shows direct variation, is to simply solve the equation for y. Okay, so we're going to get y on the left and everything else on the right. So we'll subtract the 2x because we want to zero that out, and we subtract the 2x from the other side. So we now have negative 3y equals negative 2x. Because we subtract 2x from 0, and we still just 2x. All right, so we divide by negative 3, and we have y equals 2/3 x. This matches our form, y equals kx, and so we can say that k equals 2/3. which is our constant of variation. Okay, so same thing on the question B here. We will add x so that y is now by itself. And we have y equals x plus 4. Okay, well, we have the y equals x part, right? But the plus 4 here means it is not direct variation. Okay, let's look at some more information. Determine whether x and y show direct variation, and then explain. Okay, so we could use the table to create the equation, but there's something else we could do that will help us. Okay. What we can do with the table is we can first look and see, does it have a constant rate of change? Okay, so we look here, we went up 1, went up 1, went up 1, and here we went up 2, and up 2. So we have the constant rate of change. The question is, will this go through 0, 0? Okay, so as we're looking, we went, if we go back 1, we would get to x equals 0, right? Because 0 plus 1 gives me 1. Okay, so I need to be able to add 2 to something and get negative 1. Well, let's see. It's basically saying negative 1 subtract 2, so that would be negative 3. So since it's going through 0, negative 3, it means it won't go through the origin. So this is not direct variation. Okay. Now here, it gave us 0 on the table, so we can see it goes through the origin. So the only thing we have to check here is, does it have a constant rate of change? Okay, so we went up 2, up 2, up 2, and here we went up 1, we went up 1, and we went up 1. So this does have a constant variation. And it does go through the origin, so this is direct variation. And just for they didn't ask for it this time, but k is 1/2, which you may notice is the same thing as your slope. Okay, so again, direct variation is just a line. All the properties of a line is just the special case of it has to go through the origin. Okay. The ordered pair is a solution of a direct variation equation. Write the equation and identify the constant of variation. Okay, so now they're telling us this is the solution of a direct variation equation. We know from our previous slide that y equals kx would have to be the formula. Okay, so if we have an x and a y here, we know that negative 5 has to equal k times 2. Right? Another way we could write that is negative 5 equals 2k, and to get k by itself, we would divide by 2, so k is negative 5/2. So write the equation and identify the constant of variation. So this is our constant of variation. And now we need the equation. Well, y equals negative 5/2 x. Okay. Okay, so the table shows the cost C in dollars of downloading S songs from a music website. Explain why C varies directly with S. Okay, we know from the previous slide that y has to equal kx. That shows that it's direct variation. So if I could show that 3 and 297, right, give me a solution for some y equals kx, right, then that would be an explanation of why c is varying directly with s. Okay, so another way to look at that, though, is since I have c and s and I don't have k, is I could rewrite this equation by dividing both sides by x, and then I know that y over x is equal to k. So if every pair here gives me the same k value, then I would know that c is varying directly with s. Okay? So in this instance, since we're looking at c and s, it's going to be c varies directly with s is going to give us our k value. Okay? All right, so we would start and we'd say 297 divided by 3. We found out what that equals. Let's see, 3 goes into 29 9 times with 2 left over, so it'd go into 27 9 more times. Okay, and then we take the next pair, 495 divided by 5. 5 goes into 49 9 times, and then with 4 left over goes another 9. Okay, and then 693 divided by 7. 7 goes into 69 9 times with would that be 6 left over, so then 63 is 9 again. Okay, so we have the same value for the entire table of 0.99. So not only does this show direct variation, but it also gives us our k value. So since we now know that k is 0.99, we can write our equation c equals 0.99 s. All right, let's take a look at some more information. Okay, the number S of tablespoons of sea salt needed in a saltwater fish tank varies directly, okay, that's our direct variation, with the number W of gallons of water in the tank. All right, so that statement could be translated to S is equal to K, some constant, W. Okay, that's what that statement says. So a pet shop owner recommends that you add 100 tablespoons of salt. Okay, so 100 tablespoons of salt to a 20-gallon tank, so that's W, so K times 20. How many tablespoons of salt should you add to a 30-gallon tank? Okay, so then we're looking for salt when K is 30. Or, sorry, not when K is 30, when W is 30. So we have a little issue going on here because we don't yet have our K value. So I have two variables here, I need just one. But from this information I could figure out that K is equal to, let's see, if I divide by 20, so 20 goes into 100 5 times, so that means that K has to be 5. So if K is 5, then S is equal to 5 times 30, which is 150. And that was tablespoons of salt. Okay, so that's the answer to the question, 150 tablespoons of salt. Now, I know some of you are probably thinking, well, this looks like a proportion problem. And direct variation is a type of proportionality. We could have looked at it like you did in middle school, where you set up a ratio or ratio table. Sometimes they called it 6-pane windows. Some people called it a bat and ball problem. they had all kinds of names for it. But basically what you did was you said, okay, S varies directly with W. So S to W is going to be the same, right, as 100 to 20. So what would S be if it was 30? Right? And then we used the extreme mean theorem, which said we could multiply in this direction, right? So that would give us 20S equals 3,000. And then we divide by 20, and S is, well, still 150. So that's an alternative way to work it. Right, so that's a lot of information, but those are the ways that direct variation, we can ask questions about it and how we can use it to solve other problems. So now you get started on your direct variation worksheet.